See, these are the 9-2 notes. In section 1, we learned how to graph quadratic equations. And remember, we learned that if a was positive, because we had the function f of x equals ax squared plus bx plus c, we learned that if a was positive, it made a bowl. And if it was negative, it made an upside down bowl. And we learned that these are called parabolas. Now we're going to learn how to interpret those graphs in order to find the solutions of equations. In Chapter 8, we were using factoring to find solutions, and now in this section, we're going to use graphing. Now, 3 things can happen. It can touch the x-axis twice, like this one. Those 2 places that it touches are the solutions. It can touch the x-axis once, like this one, in which case there's only one solution. And then it cannot touch the x-axis at all, which means no solution. So 2 unique real solutions, 1 unique real solution, and no real solutions. Those 3 things can happen when we graph these. Where it touches, the x value is the solution. And I'll show you an example of that right now. So on the next page, we're going to go ahead and give it a try. You should have a ruler, a calculator. Your textbook should be open to page 537, and whatever you're going to use for graphing, I use my highlighters and my different colored pens. You should pause the video right now and go get whatever you need in order to make these graphs. So the first one says, solve x squared minus 2x minus 8 equals 0. I'm going to take this equals 0 and replace it with f of x. Okay, the function of x. If this is not 0, you need to subtract whatever number is here to make it be 0. So my function is x squared minus 2x minus 8. Now, the next thing I'm going to do is, just like I did in 9-1, I have to find the vertex first. Okay? And remember, that's negative b over 2a. If you are having a hard time remembering how to graph these, you need to get out your 9-1 notes and use them to follow along. So b is negative 2, so a negative 2 makes a positive 2, over 2 times 1, which just gives me 2 over 2, or 1. Remember, that's my x value, so I plug it into the function. F of 1 equals 1 squared minus 2 times 1 minus 8. I get 1 minus 2 minus 8 gives me negative 8. Okay? Now that gives me my vertex. I have a vertex of 1, negative 8. But now I have to make that t-chart. If you remember back to the first page, let's go back here first. Where it touches the x-axis is my solution. So I can graph them, and I might have to draw in my lines to go up. I'm going to show you how we will estimate using this one, but you should also remember that you're going to get a number and 0 and a number and 0, because remember, where it touches the x-axis, you have an x value but no y value, so you get a number 0. So I want you to keep that in mind when you're making your x-y table and see what happens. So I'm going to graph this first. I'm going to say, let's see, we need to have, did I add that wrong? Yes, this should be negative 9. I'm sorry. Change that to negative 9. And so I need to have 9 places. So 1, 2, 3, 4, 5, 6, 7, 8, 9 below the axis. Okay, and I'm going to draw this one right down, maybe off a little bit to the left. Okay, I'm going to go ahead and draw in my vertex, which is at 1, negative 9. And draw in your line of symmetry. Label your point. This was at 1, negative 9. Now we're going to choose points on the left and the right of that ordered pair. Now we are looking for x values that will make 0, because remember, we're looking for a number and 0 in my ordered pair for my solutions. So let's go ahead and make our t-chart. I'm going to go ahead and make this one a little bit bigger. So that way I have plenty of room to find where it intersects the y-axis, or sorry, the x-axis. So I know my middle point will be at 1, -9. So let's start by going to the left. My first one's going to be 0. Then I'm going to go -1, -2, and let's start there and see what happens, okay? So if I have f of 0, I get 0 squared minus 2 times 0 minus 8. So I get 0 minus 0 minus 8. Okay, so my video shut off somewhere in the last one, so you're going to have to just follow along with what I have written already. But we ended up back here where we had 0 minus 0 minus 8, which gives us -8. And that's going to be the next point. We're going to do -1 next. We have -1 squared minus 2 minus 1 minus 8 gives me 1 plus 2 minus 8 equals -5. And then we're still looking for that x-intercept, so we're going to go ahead and do -2 next. So I have -2 squared minus 2 times -2 minus 8. I get 4 plus 4 minus 8 equals 0. And that's what we were looking for, because remember, when we get an intercept, we get a solution. So let's go ahead and see if we can find the other side. Remember that this is symmetrical, so I should be able to say that I'm 1, 2, 3 places from the axis of symmetry for my first intercept, so I should be 1, 2, 3 places from the axis of symmetry for my second solution. So I had -2, 0, -1, -5, 0, -8, 1, -9. Then I had 2, 3, and 4. Now 2, 3, 4 gives me that 3 places away from that axis of symmetry. Let's plug in 4 and see if we get 0 back out. So I have f of 4 gives me 4 squared minus 2 times 4 minus 8. So I get 16 minus 8 minus 8 equals 0. And that's what we wanted. So go ahead, and we know that it's symmetrical, so I can fill in -8 here, -5 here, and 0 here. There are your ordered pairs, which means my solutions for this function are the x-intercepts, which are -2 and 4. Go ahead, pause the video, and finish filling in the rest of this work, and then turn it back on when you're ready to keep moving on. So I gave you the example -x squared minus 3x plus 18 on the next page. That one gives us decimals and fractions, and we don't want to deal with those, so I'm going to have you cross that one out, and we're going to redo it as x squared minus 4x plus 3 equals 0. Example will give us whole numbers that we want to deal with. So remember, the first thing I have to do is replace 0 with f of x. So now I have f of x equals x squared minus 4x plus 3. Find the vertex, so I have -b, -4 gives me +4, over 2 times a, which is 1, so I get 4 over 2, which is 2. Then I plug that x value into f of x, so I get f of 2 equals 2 squared minus 4 times 2 plus 3. So I get 4 minus 8 plus 3, which gives me -1. My vertex is at 2, -1. And then remember, I'm going to go ahead and I'm looking for where it crosses the x-axis. But when I draw in my graph, I know that I'm already starting at 2, -1, and it's opening up, so it should be pretty close to the intercepts. Okay? You can draw your axes in. I drew them both pretty much in the middle, so you have your x and y. I have my vertex at 2, -1. Draw your axis of symmetry in. Then I'm going to make my t-charts, and I'm going to choose x and y values on both the left-hand side and the right-hand side. Numbers I'm going to choose are 1 and 0 for the left-hand side, and then 3 and 4 for the right-hand side. So I'm going to go ahead and start with 0. F of 0 gives me 0 squared, which is 0, minus 4 times 0, which is 0, plus 3. So I get 0 minus 0 plus 3 gives me 3. And then 1, I have 1 squared, which is 1, minus 4 times 1, which is 4, plus 3. So I get 1 minus 4 gives me -3, plus 3 gives me 0. I know that I have the ordered pairs 0, 3, 1, 0, 2, -1, and then I have 2 places to the right as well, and it should be symmetrical, so I can just say 0 and 3 here. So I get 3, 0, and then 4, 3. So my solutions are where it crosses the x-axis at 1 and 3. Pause the video, finish drawing in your graph and any information that you might have missed, and then move on to the next page. Okay, so sometimes you're going to get two solutions, but they're the same number. That's called a double root, and what that means is if you look back at the very first page of your notes, it means it touches it in exactly one place, which means you'll only have one solution. So we're going to solve this one by graphing first, and then we're going to solve it by factoring. So the first thing we're going to do is we're going to move that -9 to the other side because I need them to be on the same side so that I get equals 0, so I can replace that equals 0 with f of x. So I add the -9 to both sides. I get x squared minus 6x plus 9 equals 0. Replace that 0 with f of x. So now I have f of x equals x squared minus 6x plus 9. Start by finding the vertex. So I take negative b. B is -6, so a positive 6 over 2 times a. A is positive 1, so I have 6 over 2, which gives me positive 3. Then I have to plug that 3 into my f of x. So I get f of 3 equals 3 squared, which is 9, minus 6 times 3, which is 18, plus 9. So I get 9 minus 18 plus 9 gives me 0. So my vertex is at 3, 0. So I'm going to go ahead and draw my line in, and I'm going to draw the vertical vertex off to the left, and my horizontal vertex down at the bottom because it's already starting at 0 and it's only going to move upwards because my A is positive, so it opens like a bowl. Okay, so my vertex is at 3, 0. Draw in your axis of symmetry. And then we're going to pick values on the left and the right. So I have x and y values. 3, 0 is my vertex. So to the right I'm going to do 2 and 1. And then I'm on the right hand side, or sorry, to the left I'm doing 2 and 1. And then on the right I'm doing 4 and 5. I'm going to start plugging those in. So f of 1 gives me 1 squared, which is 1, minus 6 times 1, which is 6, plus 9. 1 minus 6 gives me -5, plus 9 gives me positive 4. So I'm at 1, 4. F of 2 gives me 2 squared, which is 4, minus 6 times 2, which is 12, plus 9. 4 minus 12 gives me -8, plus 9 gives me positive 1. So I'm at 2, positive 1. And I know these are symmetrical, so I can write 1 and 4. So I'm at 4, 1 and 5, 4. And then I can draw in my curve. And I'm going to label my vertex, which is also the only place where it touches the x-axis, so it is my only solution. So my solution is just 3. Okay? Moving to the next page. Sometimes we get no solutions. Remember, if you look at the first page, this one never touches the x-axis, so it has no solutions. So go ahead and we're going to start by finding the vertex, replace 0 with f of x. So when we have f of x, we have 2x squared minus 3x plus 5. And I'm going to find my vertex, so -3 gives me positive 3 over 2 times a, which is 2, so I get 3/4. So I'm going to plug in 3/4, and I get f of, and I'm going to do 0.75 instead of 3/4, gives me, let's see, 2 times 0.75 squared, which gives me 1.125 minus 3 times 0.75, which is 2.25, plus 5. So 1.125 minus 2.25 plus 5 gives me 3.875. So my vertex is going to be above, so I'm going to draw in my axis at the bottom. That's going to be on the right hand side, so I'm going to draw this a little bit off to the left. And it's at 0.75 and 3.875. So it's about 3/4 of the way, and then up 1, 2, 3, and almost to 4 is my vertex. Now I'm going to pick whole numbers to the left and right of this, so it won't be symmetrical, so we'll have to fill in all of those ordered pairs. So I have x and y. My vertex is at 0.75 and then 3.875. I'm going to go with 0 and -1 on the left, and then I'm going to go with 1 and 2 on the right. Now, notice these are not the same distance from the vertex, so they will not be symmetrical. We will have to find all 4. So let's start with -1. F of -1 gives me 2 times -1 squared, which is 1, minus 3 times -1 plus 5. So I get 2 plus 3 plus 5. That gives me 10. Then I have f of 0 gives me 2 times 0 squared, which is 0, minus 3 times 0 plus 5. So I get 0 minus 0 plus 5, which gives me 5. I have f of +1, which gives me 2 times 1 squared, which is 1, minus 3 times 1 plus 5. So I get 2 minus 3 plus 5. So I get -1 plus 5 gives me 4. And then f of 2 gives me 2 times 2 squared, which is 4, minus 3 times 2 plus 5. So I get 8 minus 6 plus 5. So I get 2 plus 5 is 7. So my ordered pairs are at -1, 10, 3, 6, 9, 10, 0, 5, so 5, and then 1, 4, and 2, 7. So notice how these are not symmetrical, so you have to be very careful of that. So draw in your curve. Okay, I'm also going to draw on that axis of symmetry. Okay, so my solutions are where it crosses the x-axis. It never crosses, so it's no solution. Okay, that's the end of the notes. I'll see you in class tomorrow.